substitution. 1 and 2. -3, -6 before. 5, -1, -2. 6, 0. 7, 5 times 0. 8, a pair of -4s. 9, -4, 1. 10, 4, 1. 11 and 12. Good for you. 13, 14. 15, 16. And options do my favorites. 17, cheesecake $5 for the New York chocolate marble 11. 18, bag. 12 balls, $4. Bag of bonuses, something. And 19 and 20. And 11 boost 44. Adult tickets 11. Something else, something. Was the best of times, was the worst of times. This would be the part where you may or may not ask questions based on results, answers. So this test is going to be strangely similar. As hard as that is to believe. Stritzel?
Could you do number 6, please?
My Intercept promo 6. Really? Number 6. Yeah, you might want to grab some notes to jot down tonight. So, see what number 6 looks like. Number 6. We're solving this by what? What are you told to solve by?
Elimination.
Elimination. So when you do elimination, basically your first thing is you're looking for, are there opposites that when you add it together are going to drop out? Do I have to change this to get some opposites, or does it already have opposites? It already has opposites, right? There's a negative y, and there's a positive y, correct? So I can just put them together like that. I don't have to do any multiplication or anything. Add together, what's going to happen? Well, first thing that happens is those y's are going to drop out, so let's just get rid of them. Negative 6x, positive 9x is 3x, is correct? And a 7 and a minus 7 is 0. Can I have that? Absolutely. You can divide 0 by 3. X is going to be 0. Is that what you had, Grace? No? Then, just because x is 0 doesn't mean that y has to be 0. You're going to take 0 and put it, doesn't matter which one of these two, just put it in for one. Let's take the top one. Negative 6 times 0, what x is, minus y equals 7. This goes away. You get minus y equals 7, so a positive y equals negative 7. It's 0, hopefully 0, negative 7 is the answer there. Caitlin, where did we go wrong?
I I just didn't get why.
Can you get y now?
Yes.
Okay. Alex? Number 4. Substitution, elimination, graphing, what? Substitution. Well, unfortunately for this one, it's already solved for y, right? So I'm assuming you took what y equals and put it in for y in the other equation. So you have the negative x minus 2 times what that y equaled, which was 6x plus 12, and that equals this 15. So far, so good? It's negative x, you have to distribute out this negative 2. Negative 2 times 6 is negative 12x. Negative 2 times positive 12 is negative 24. You get both those. A lot of times people make mistakes when they multiply by the negative 2. Equals 15. Combine negative x, negative 12 is negative 13x's. Add 24 to do its opposite. Add 24, and fortunately for us, we get 39, which is a good number because 13 doesn't go into a lot of numbers. Divide by negative 13. Divide by negative 13. You end up with a negative 3. Did you get that, Alex? So, it does not matter at this point which one you put the x into, as long as you put it into x. I'm going to do the top because it's already solved for y, and then I really don't have much work to do. So, y equals 6 times what I got x to be. 6 times that negative 3 plus 12. Y equals negative 18 plus 12. Y should equal a negative 6. So negative 3 common negative 6 would be what the book should have given for the answer. Seems like we're struggling with this part, putting it in the other thing and getting the other things there. Joe Hammer?
Can you do 20?
I would love to do 20. 20 right there. Is that 20? Is there all the words there? Do I have to go way over here? Oh, maybe it's- let's see if we can't do this here. The school that Eugene goes to is selling tickets for a fall musical. First full ticket sales sold 5 adults, 5 students. Oh boy. So you've got what, Kayleen? You define the variables to be adults and students, I hope? What'd you make students be? David, was it? Students. And A is adults. That's what I would have done. So 5 adults and 5 students was $105. 5 adults plus 5 students was $105. The school took in 143 on the next second day by selling 3 adults and 11 students. 3 adults plus 11 students equals 143. All right, from here, Kayleen, what'd you do? And again, here's one where, you know, these don't, this is about as much work as you're going to have to do because neither one of them are opposites or the same factors, so you need to change them. You know, what do you do to 5 and 3 to get a common multiple? What do you do to 5 and 11? What'd you do?
I did multiply the 5 adult and 5
Yeah, by what?
3.
A positive 3? I'll do it your way. So, if you multiply these all by 3, what are you going to have to multiply the bottom one by? A negative 5, because you want these to be opposites, and 15 is your common whatever thing here. So if I do that, oh, we get some interesting multiplication there. I'm going to pull it up here. 15a plus 15s equals 315. In concurrence there. On the bottom, negative 15a, which is what we want because they're opposites, minus 55s. How about this multiplication here? 5 times that, how about 715, yeah? Negative 715? You still in the same place, Kayleen? equations together, this goes away, you end up with a negative 40s equals negative 400. Still in the same place? Did I do something wrong?
No, I think
And everything looks like it's gonna work out. Divide by negative 40, divide by negative 40, two negatives gives you positive. That would give you 10 student tickets. Or actually $10 for a student ticket, I believe. It's not 10 student tickets, it's $10. And then the adults, it doesn't matter, you can pick any of these 4 equations to put that in to find your answer. I would probably pick this one just because 5a plus 5 times 10 equals 105. 50, subtract 50, you get 55. 5a equals 55. So a is going to equal $11, the ticket. M. Willman. Another story problem? Just a little bit. 19. How's that? Can I see it all there? Alright. The way it is. Local amusement park is a popular field trip destination this year. Senior class high school A and the senior class high school B both planned trips there. The senior class A rented and filled 4 vans and 9 buses with 440 students. B rented 11 vans, 12 buses. Each van has the same number of students in it as did the buses. How many students can a van carry? Alright, so your unknowns are B. Did you use B for vans? No. No. B for vans. Where are we right there? That's kind of small. Alright, B is vans and B is buses. And it said what? 4 vans, 9 buses. Plus 9 buses, and they carried a total of 440. Second equation was 11 vans and 12 buses. Well, these are a little tougher than your normal ones. And they carried what? 649. Some harder numbers to work with, but you really should be able to do this. It's not that hard. This is probably why David went for a calculator yesterday. The question is, what can you change these two so they're common denominators or common multiples? What did you change them to, or didn't you? If these are on the bottom of fractions, what would you use for your common denominator? If I had 1/4 plus 1/11, what would I make the bottom numbers of my fractions to be? 44. So that's going to be probably what I'm going to do here. And it doesn't matter which you make negative or positive. I would probably, I don't know, let's do the top as positive. You're going to multiply everything by 11 here. Wow, is that the best we can do? And negative 4 on the bottom to make them opposites. And I don't have much room to do that. Suggestions where I can do that? I'll do that here. No, I won't. I'll go over to the side. I'm going to get rid of this one. So you get 44b plus 99b equals 11 times 440. 4,840. Anybody do this problem? Can you get that? Am I here on my own? Next equation, if you multiply everything by a negative 4, you get negative 44b minus 48b, and negative 4 times 649. Wish I had David's calculator. 36, 3, 16, 19, 1, 25, 96. Negative 25, 96. Add them up together, it goes away. What is this, 51? B equals, subtract because that's negative. Is that gonna work out? Maybe, maybe not. Divide by 51, divide by 51. 2, 4, 4 divided by 51. What do we get here? 4 is 204. Subtract, we get 204. Look at 44. What is 44? Since you have the letter B there, that's what B is. That's the number on a bus. A bus can hold 44. And then you'd have to solve for the letter V. How many a van can hold? You'd have to put 44 in for the bus. Anywhere over here, let's put it right here. 9 times 44, that's 36, 396. Subtract 396. So 440 is 56 divided by 4 is 14. I'm not gonna. You should be able to do that part of it. I hope I got it right. Some of you are, I can tell, either mesmerized or sleeping. Which one is it, Grace? Go with mesmerized, that makes me feel better.
Pretty sure you said that B was 11 for answer.
Alright, let's make it 11. So I have to do I have to go back and find what?
Yeah, it is.
Do I have to go back and find the mistake? Can you just accept that I was trying to go too fast? Alright, okay. So here I was at 440, I wanted to subtract 396 from it. I ended up with 44 divided by 4 is 11. Yep. Yep. That was good. Way to catch me on that. Logan's face.
How do you graph your inequalities?
How do I or how do you? Give me an example problem. You didn't watch my video?
No.
Really? All that work?
Look, you've been so safe. You 11. Yeah, we said hi to you guys.
I know. You made special. I'll do 11, I guess. I won't do 11. Alright. Logan, you do inequalities just like linear equations. In other words, you look to see is it in slope-intercept form or is it in standard form? That's in slope-intercept form, right? Solve for y. That is the y-intercept, so you put a dot at 5 on the y-axis. And what's the slope? 2 over 1. And it's a positive slope, so you go down 2 over 1. Now, here's a couple things to keep in mind. If there's no equal sign under the inequality, you make a dashed line because it starts there but doesn't equal there. So here's my dashed line. It's the same line you did if that was a linear equation written up with an equal sign. And then the only hard part with some people have a hard time grasping is this. Because you're doing anything less than that, you look at the y-axis, maybe put your finger where it crosses the y-axis, and you are going to shade in the side of it that is where y gets less than. Y keeps going down this way, so you're going to take and you are going to shade the less than side. And the only problem you have to watch out for is if y is actually negative, that actually flips around and you shade the opposite of what that says. Was there one of those in here? No. Here, I'll do this one real fast.
Column 16.
Crosses the y-axis at -1. Slope is -1/2, so up 1 over 2. It's going downhill. There's no equal sign, so it's a dashed line. And put your finger maybe where it crosses the y-axis, and again, y is less than, so where y gets smaller than that's what you're shading. I'm going to make my shader a little bigger. Which one did you say, Ryan?
No, I was going to be an example for
These over here, Logan, okay, you're graphing the same thing, and your answer is, there's two different ones, and the part that gets overlapped is your answer. So we'll do 16 just because I'm sure somebody wants us to do 16, right? Now these are in slope, or these are in standard form. So you can graph with x, y intercepts. And right away, children, all of you, y is negative there, so in the back of your mind, you gotta be thinking when you end up shading, you gotta change that sign. So this one here, crosses, if I solve for y is a -3 into a -3, which is +1. X is -3 divided by 2, which is -3/2, which is -1.5. It is an equal sign, so it's a solid line. I'll try again, it's a solid line. It's a -y, so that sign, put my finger here, I would have shaded the top, but it's negative, so I will shade the bottom. Not quite so big. Then I graph the other line. Again, y there, y-intercept is -3, right? -9 divided by 3, so I get a -3. This one -3, this one 2, 3. X is -9/2, 9 divided by 2, which is -4.5. Not an equal sign, so I dash it on dasher, on dancer, on dancer, on vixen. I'll put my finger there. What side of it am I shading? It's greater than side, so I'm looking at this blue line. I am shading everything blue going that way. So everything blue going this way. And the answer, the actual answer is any place where those that overlap, where they both shade the same part. So my shading is going to be this whole piece right here.
What's the colors?
And Wilman,
215.
I won't, but since I'm there, I will. Again, this one knocked me over because it's a -y. Both my x and y, well, x-intercept is 3. Did you get that, Madison? You didn't? You did. Y-intercept is -3. Equal sign, so it's equal. What side am I shading? The less than side because y is negative, so I'm going to shade this. Graphing the other one, y-intercept is 1. X-intercept is 1/3, 1 divided by 3. Which doesn't make a nice picture there. We'll get it close. And it's equal. What am I shading on that? The less than side. So where this crosses the y-axis, should have been right there. I'm shading everything that goes down from there, which means this. And the answer is any place you see blue and red together, it looks like it happens to be right here. Did you get that right?
Yep.
I am prone to making a blunder every time. Grace!
Could you do 7
Look, we didn't need a birthday treat, shall we?
and
Oh. What if somebody needs their sugar now, as most of these kids appear to? I'm sorry, Grace, which one?
Could you do 7 and 10?
7 and 10? The 7 on the second page? I will do 7. Why not? 7. Am I solving, which method am I solving by?
Elimination.
Elimination. So, Grace Watson, what am I gonna do?
So isn't this, since the second one's already opposite, can you do it?
The second one is not opposite. Now, these two are, but they're not the same number, so it doesn't really help you.
That's fine.
Because when you add them together, it needs to be the same, same coefficient, the same number in front of the variable to be opposite. I mean, you could multiply this top one by 7 and this one by 4, and then they'd be opposites and you could do it. But this one, these are already 6s, so the fix is just multiply one, either the top or the bottom by -1. I multiply this by -1, -1, -1. Now I will have opposites. I will have a negative 6x, a positive 7y, and a negative 30. And this whole thing goes away. And then when you add them together, 6x minus 6x goes away. 7 and 4 is 11y, and unfortunately that equals 0. So we're back to another divide by 11. You can divide 0 by 11, so y equals 0. Put 0 in for y right here. 4 times 0 goes away. 30 divided by 6 is 5. So when they're opposites, they have to be the same number opposites. It's not just that 1 minus 1 plus, they both have to be the same number. You said 10? Is 10 the same thing? Turn over here. This was by elimination as well? Is that a 9? I'm assuming that's a 9. So here's you kind of got to be your own boss a little bit in this. What's the easiest thing for you to do to get them to go away? Who got this right? You don't have to do the exact same thing. Claire, what did you make what? You go 8 9s or 72s? Or did you do 3 and 5 and multiply by negatives?
I did the 3 and the 5 and I made them both 15.
Okay, and then you must have made one negative. You must have multiplied the top or bottom by negative.
I multiplied the bottom.
Fine. And I don't care, Grace. Did you try? Did you? Alright. We got that going for us. And it doesn't matter. I personally probably would have multiplied this one by 9 and this one by 8 just because I didn't have to worry about changing negatives and positives, but it doesn't really matter. I will, Grace, what do you want to do? I don't know if there's necessarily an answer. Sure, I'll do this. I'll multiply the top by 9s and the bottoms by 8s. Oh, let's rewrite them all over. So the top I get negative 27x minus 72y, negative 180. Bottom one is negative 40x plus 72y equals negative 88. Well, that worked out nicely, didn't it? Add them together, the y's are eliminated, hence the reason we call this elimination. Negative 27, negative 40 is negative 67x. Oh, look at that. What's that? Negative 268. One can only hope that 67 goes into 268, otherwise I think we did something wrong. And if I had David's calculator, we wouldn't have all this messy stuff here. I believe 67 goes into 4 times. So your letter X is 4, and your letter Y, negative 5 times 4 is negative 20. Add 20 to this, you get positive 9. Hopefully Y is 1. Unless you want me to slow down and do that. A little bit more jurisprudence. I can do that. Smile, David. Thursday. What's that? Thursday. I know. Tomorrow's Friday. And then next week really is a 3-day week. Wonka Fest and no school Friday. There's a beer term. No, midwinter break, thank you. We don't take school off just for basketball. Schwartz.
You do 9.
Will I do 9? Watson, did you get this one right? Because if you didn't get those other ones, I'm not so sure this one.
No, we have to do that.
Mia, what am I gonna do? What can I do to get them opposites? By what? Then multiply the top by 3 and the bottom by, see that'll give you a positive 12x, you need the bottom to be a negative 12x, or unless you multiply, yeah, we can multiply the bottom by it. See, getting a 12x there does you no good unless there's a minus 12x. Getting a 18y there does you no good unless there's a minus 18y. You gotta figure out what to do to get them both to be opposites. So if you multiply the top by 3, I would multiply the bottom then by 4. Because that gives you a positive 12 and that gives you a negative 12. then, once again, multiplying it out, you get 12x plus 18y equals negative 30. On the bottom, a negative 12x would be minus 28y equals 20. Now when you add them together, these are completely opposites, go away. Negative 10y equals negative 10, divided by negative 10, divided by negative 10, y equals 1. Put 1 in for y in any of these, I'll do it here. 4 times x plus 6 times what I said y was equals negative 10. I get 6 here, so I subtract 6, which is a negative 16. 4x equals that, so x equals negative 4. Is that the answer, Ryan, Connie, you got this morning just before school when you did your homework?
No. That's what I did before this morning.
Oh, you did? You got past number 9. Good job. Way to work beyond your ability. Claire?
Could you do number 13?
I love 13. Is that on this page? Is that on the next one? Have I done 13 before? How come it doesn't appear that number here for 13? Is that this one?
Yes.
Do I need to be able to see what it talks about? How do I get it smaller? One more. Hi, Claire. Mark what you see here. Oh, look, no negative y, so I don't have to worry about shading the way it is. How do I graph the top one?
Down negative 3?
Well, yeah, well, the y-axis, negative 3, that's the y-intercept, thank you. What's the slope of that line?
It would be down 1 over 1.
Or up 1 over 1, yeah, it's positive 1 slope, so up 1 over 1 would just be perfectly okay. And it's not equal to, so it's a dashed line. And what side am I shading? The less than. So you start at the y, put your finger there. Where does y get less than? When you go down. So this whole thing going down gets shaded with. Second one, kind of the same spiel. It's in y. It's in smoke intercept crosses the y-axis at 2 and has a negative 4 over 1 slope. It goes up or down 4 over 1. 1, 2, 3, 4 over 1. And it is equal to, so it is a solid line. Putting my finger here where it should have crossed the y-axis, y is greater than, and y gets greater than as you go this way. So you're going to shade the top, even though it looks like sideways. And the part where they cross, the part where it is doubled up, which looks like right here, 2 right here, is hopefully your answer. You tell me if I did something wrong. Noah is as confident as can be that this is going to be the easiest A he's ever got in mathematics. And he just cough. Was that a nervous cough? Real cough? Yeah. Fully filled up. Alex Houts! By re-explaining, I already did it once. Absolutely. Rome was not built in a day. Number 10. I'll even erase it. And make it larger. One more time on 10. So Alex, we've got to find opposites if it's elimination. So you look at those numbers there and you say, what can I do to them to get one to be positive some number and the other one to be negative that same number? And again, we do it all the time in fractions. If you're trying to find common denominators and these are your two denominators, what number would you make it? If this was a number, you'd make it 72. And it's your choice which one you want to do. You just need to make sure that in addition to making them the same, one of them needs to be negative, one needs to be positive. So your call. We'll do, I mean, we'll multiply the top by 5, right? We're making 15s. If I multiply the tops by 5, and I multiply the bottoms by 3s, I get 15, but they're not going to be opposites because these will both be negative. So you got to pick one to do by -3 or -5. It doesn't matter which. Your call. Bottom by -3s. So rewriting on both of these equations somewhere down here, you get -15x. 5 times that is -40y. 5 times that is -100. The second one, you get positive 15x, which is what you want, so they drop out. Minus 27y equals positive 33. Add those two equations together, this goes away. Negative 67y equals negative 67. That's not so bad, because y equals 1. And again, like I said, it doesn't matter which one you put it into. I'll put it in this one just because. Negative 5x plus 9 times what we said y was equals negative 11. This is 9, subtract 9, you get negative 20. Negative 5x equals negative 20, divided by negative 5 by negative 5, x equals 4.
Like that projector could read my mind, so.
Stritzel,
Could you explain more graphing, because I still have that trying to do most of it,
which one?
just any of them.
Well, give me a number, because I'm so close to the board here, I don't.
14.
14. Which one am I on? 2. What did that have? 10. 14. And Caitlin, it's, I mean, you have to be able to graph linear equations.
That's the part I don't get.
Well, that's what, I mean, we've been doing that since like seventh-ish grade. You have to understand what form this is in. What form is it? Slope intercept, it's solved for y. The number all by itself, and this is what I write. Do you write this down? This is where it crosses the y-axis.
Yeah, I get that part.
Alright, so you get the 1, right? And the other thing you need to know is the number in front of the x is its slope. So what does that mean?
So,
Up 1 over 3. And you have your choice of whether to go up, whether to go over 3 that way or over 3 that way. That's what this negative tells you. It's negative slope, so it has to go
right?
downhill. So you're going to go downhill. This one it's equal to, so you can do a solid line. If there was no equal sign there, it would be dashed. So you have trouble graphing lines like that?
No, just the other ones.
Which ones? The ones that are not in slope intercept form?
The ones that was already been over.
For example, not that one. Because this is still slope intercept form. Are you talking about the ones in standard form?
Yeah,
Like this one?
yeah.
Okay. Well, the first thing you have to do is recognize that it is in standard form. What's the difference between that and slope intercept form? These are not solved for y. Both x and y are on the same side of the thing. Okay? So that means it's in standard form, and you solve that by covering up things and seeing where they cross the other x and the y axis. For example, if I cover up the x, what am I left with? Negative y is greater than or equal to 3. And you have to say, well, if negative y is 3, what does y equal? Don't say 3.
Oh, negative.
Negative 3, right, because of the negative y. So you put a dot at negative 3. Then you do the same thing for y, cover it up. What does x equal?
3.
3. Those are the 2 points you use to make the graph. It's equal, so you can. Same thing for this one. Cover up the x, where does it cross the y-axis?
1.
1. Good color here. Cover up the y, where does it cross the x-axis? Maybe this is where it's giving you trouble.
Yeah, that's where it does.
Well, it's always this number divided by this number when you solve it. What is 1 divided by 3? And write it out. Okay. You get this. Divide by 3, divide by 3. Unfortunately, it's a fraction. It's 1/3. Where's 1/3 on the x-axis? Well, it's between 0 and 1. It's 1/3 of the way. So it's right there, and that's going to be close enough. And that gives you 2 points for your line. Shall we do another?
Yes.
Through the magic of television. Huh? So you tell me, where are the x and y intercepts for this one? Where's it going to cross the y-axis? Where's it going to cross the x-axis? That one.
Y crosses at 1.
Y crosses at 1. It's the same thing. Maybe you gotta write it down. Let me get rid of this and write down. If you have 2x and a negative 3, you divide by the 2. What is that fraction?
Negative 3 over 2.
Which is where on the x-axis? As a mixed number, it's what?
1 and 1/2.
Right, so negative 1 and 1/2. So there's your other x number. How about the next one? X and y intercepts? Y is
Negative 3.
negative 3. X is, same thing we did before, you get 2x, divide by that 2. That's a mixed number, that is
4 and 1/2.
negative 4.5, so it's between negative 4 and negative 5. And there's your other one, and it is not. I'm sure if you go on the website and look at graphing by standard form or something like that, but probably not quite like that. Does that help?
Yeah, it does.
Jot yourself some notes. Are you done, anybody? I can tell you're all. Wishing that was what? You're all. David is still mesmerized. Or dazed and confused. One of the two. No? Yeah, no. I will send this. Oh no.